Okay, so we're going to be adding in the movement, and I'm going to take you to at least the place where I have my game target stuff. That's going to be in my play function, or game function, I guess it's called. Yeah, right in here. So in void game, that's where I draw my ellipse. So we're going to have to make a few changes. We're going to not always be drawing our ellipse at the same place anymore, right? Because it's going to be moving. So we'll replace that with x and y. If I just type in x and y, I'm missing out on an important thing, right? That's going to be our variable declaration. So maybe we'll just plan this out. I won't type it in yet. But those are going to be some variables. We also talked about the vx and vy variable, so we'll have to go get those things as well. So before I add that in, I'll go to the top and add those variables in. I'm going to make them floats because it's possible for it to be, halfway between 1 and 2. So I'll say float x, float y, float vx, and float vy. And I think actually I will put them on separate lines just so I can add in a comment here. So x and y will represent the center of the target. And vx and vy will represent how much the target, how many pixels the target moves each frame. And of course, the positiveness and negativeness of this will matter quite a bit. Okay, so I'm still going to have the target start at the center. So I'm going to say x equals 400 and y equals 300. I'll still do that. That might not be the center of your screen, so I'll let you guys decide what that's going to be. And then let's just, for fun, put in some like vx and vy. I'll say vx is going to be 4, vy will be 4. I'll just type in those numbers. We'll experiment with some other numbers. Hey, off the top of your head, what direction is that going to be? Yeah, it's going to be, it's like, do you do it my perspective or your perspective? Yeah, it's going to be going to the right because x is increasing, and down because y is increasing. It's kind of awkward, right? It's a little bit of, like, yeah, it kind of makes sense, but it'll take some time to, like, really make it intuitive. So we expect it to go kind of to the right, to the right and down. All right, so let's go and add that in. So in the draw function, no, not in the draw function, in the game function, what we have to do to make this work is we have to replace the ellipse's x and y coordinate with the variables x and y so that they can change. And then we're going to make it so that every frame we increase x by vx and we increase y by vy. And that right here, those two lines of code, this creates movement. It's not that different from what we did with the animation project. The animation project, we just had x usually. Some of you made the sun rise and fall, and I did a bit with y. But for the most part, we just did x equals x plus 5 and make it go slower. Maybe the mountains went x equals x plus 3 or something. So it's really the same thing. It's just that we want to change that speed. So instead of just making it go up by the same number over and over again, we'll make that a variable as well. And that way we can change that for things like bouncing and increasing the speed and so on. Okay. So let's run this and see. Does it actually move the direction we expect it to go in? Let's start. Hey, look at it go. Bye, target. See you later. But it worked. And just to show that it does actually work, let's just do a couple more interactive things. I'm going to change this to vx is -4, vy is +4. Can you imagine a quiz question one day where it's like, I'll give you like positives and negatives? You can just imagine that, right? Okay. Well, try it out right now. Here's my values for vx and vy. What direction is it moving? Here I go. Whoops, I pressed something wrong. Try again. It's going to the left and down. And we could play this game all day long, but we probably won't get into it too much more. Here we go. Oh. What if I made vx 0 and vy -4? It will go straight up and so on. Okay, so we got some kind of movement going on. The hardest part about this is going to be bouncing. If the movement makes sense, then if we take a look at what bouncing means in terms of Vx and Vy, we can make that happen. It turns out there's actually a pretty simple bouncing code to add in here as well. It's simple if it makes sense. If it doesn't make sense, it's so confusing. So I'll try to do a good job of drawing an example of some bouncing. Let's take a look at some bouncing. I wish I had a more tactile example here. This coffee filter is or whatever this is fairly elliptical. So I'm going to animate this with the power of my hand. Wow. Imagine this is your screen. So if our Vx and Vy was, I don't know, say Vx is 5 and Vy is -5, that's going to generally move 5 this way because our Vx is 5, and it's going to move 5 this way because our Vy is 5. So every frame is going to move like that. That's a little bit exaggerated. 5 pixels is not very much, but just so that you can see what's going on. So every frame is kind of moving along this line. When I hit here, what's going to happen? It's going to bounce this way, right? Yeah, but what flips? So this bounces like that. This movement here is 5 and 5. Vx is 5, Vy is 5. This movement here, what's what? What's Vx and Vy if we were to take a look at this slope here? Yeah, notice Vx is still 5. When it hits the top, it's still moving to the right. But Vy is now going to be negative. So bouncing off the top means that Vy goes from positive. Oh, no, sorry. Other way around. Yeah. Thanks. Vy is -5, isn't it? Whew. See? If I was on the top of my game, my explanation would not reach all of you. So what do you think it's going to be like when I'm not on top of my game? So definitely, thank you for your clarification questions. So actually, it went from -5 to +5. That's how we got that bounce happening. What about on the bottom? Here, I'll erase this. Let's see if that's sort of similar for the bottom as well. Here's my my ellipse. It's going to start down here. What would be a Vx and Vy? Maybe we'll go this way. Maybe it's moving this way. What would be a Vx and Vy that would get me moving in this direction? Go for it, Ryan. Yeah, so I could say, let's go with negative Vx, and positive Vy. So that's how it's moving, right? It comes in, and it's going to bounce off this way, right? Still moving to the left. So Vx isn't affected by bouncing off the top or the bottom, right? But what happened to Vy? It went from it went from positive, now it's going up, so it switches to negative. So off the bounce, we go Vy equals -5 this time. Vx is the same. So bouncing off the top and bottom walls of a sketch, any bounce that happens off of the top or bottom, it doesn't matter which way we're going, all the bounces off the top and bottom walls basically just flips the positive and negative of your Vy. Vx doesn't change at all. In other words, bouncing off the top of the sketch doesn't change if you're going left or right. It just changes if you're going up and down. So let's take a look at that. How do we make that happen? So first of all, we have to decide when is it that the target is bouncing off the top of the screen. So just to keep things simple right now, I'll talk about, in my code, what it would look like for the center to hit the top of the screen. And then I'll let you guys kind of advance that to figure out how to detect if the edge of the circle is hitting the top of the screen. because that's not too different from some of the things we've done before. But we'll just make a simple decision here for bouncing. I'll move this down so we can all see. So if hitting the top means that it goes from negative to positive, and hitting the bottom means we go from positive to negative, what's that operation that like flips a negative sign? What's the mathematical operation to flip a negative sign? Yeah, if you multiply by -1, it flips it, right? Negative times a negative is a positive. A positive times a negative is a negative. So we can use multiplying by -1 to effectively switch the direction. So I'll check to see if we're bouncing off the top first. I'll say, hey, if we're at the top, so in other words, if y, you could say equals 0, but that's unlikely for it to actually always hit 0. So I'll say if it's less than or equal to 0. Then I want to switch it, right? So I'd say vy equals vy times -1. And times is just the asterisk. So that takes care of the top wall. I'm going to add in some code here, but ultimately we aren't going to include it. So you can just watch if you want. But I'm going to do the bottom wall now. So if y is greater or equal to whatever the height of your project is, I think mine is 600, then we multiply it by -1 as well. Vy equals vy times -1. Does anybody see a way we could simplify this? Yeah. Although it wouldn't be and, because it wouldn't be hitting the top and the bottom. It would be hitting the top or the bottom. Yeah, exactly. So instead of doing two different if statements, which have the same consequence, I can just take this condition and I can say, hey, if we hit the top, oops, or we hit the bottom. So or is the two vertical lines. It's right above the enter key. Hit shift and there's like a backslash or the vertical line. And then that condition there. And somehow I failed to delete. There we go. So in other words, this bouncing is if we hit the top or bottom wall, I'll just put top or bottom, then you just reverse or invert the Vy. You make it go from going up to going down. You make it go from down to going up. Let's test to see if that works. I'll set up a nice little scenario for this to be going on. Let's do 2 and -2. So 2 means going to the right, -2 means going up. If it hits the top, we'll times Vy by -1. Let's see if it works. Go. Hey, it bounced in a fairly satisfactory way. It's a little bit, the target's a little bit on the large side. Let me just shrink that down a bit, just so we can see it a little bit better. I'll make it 50. You guys can keep your target the same place. Looks good. What if I go down to start with? I'll make it go it's too far. I'll make 3 and -3. It'll go the other way. And hey, that works. So notice that when we're hitting the top or bottom wall, it's just a matter of changing Vy. And this is why this equation, if I'll scroll back to it, that's why this equation is so awesome for video games. Because changing direction is just a matter of multiplying by -1. So that's really nice when you can turn something into math for computers. Because you know what? Computers are really only good at doing math, so that's good. So if that's how the top and bottom walls work, what do you think is going to be the way that the left and right walls are going to work? You got it. It's the exact same thing, but with x. When you hit a left or right wall, it doesn't change whether you're going up or going down. If you run into the left wall, if you are going up, you're still going to go up. You just end up going to the right. If you were going down and hit the left wall, you're still going to be going down on the other side of that impact, but now you're going to be going to the right instead of the left. So you just have to invert Vx. And so I'll put this if statement. So I'll say, hey, if x is less than or equal to 0, or x is greater or equal to the width, I'll just type in 800. So in other words, we have a collision if we hit the left or right, then we're going to multiply Vx by -1. Because whether Vx or Vy is positive or negative is the direction for that particular kind of movement. So we want to flip it. So now we should get that little target bouncing around and contained inside of our screen. And I'll just put that on the side so you can still take a look at it. It's like a remarkably small amount of code, and we can just kind of walk away now. And it's just going to be bouncing endlessly. And I really think this is, I don't know if I use the word beautiful, but it's really elegant, I think is the word I would use. I'm not saying this as if it's something I've invented. Don't worry. This was invented probably before I was born even. And it's just been the way that movement on computers has been done. Does this work for all kinds of movement? Let's just double check. What if I was to make it just go straight up and down? So Vx is 0. Is that going to break at all? Nope. It'll just kind of hit the top and bottom, just kind of bounce between those two areas. It's a kind of boring game, but it's all right. It's a good start. Hi. Oh, what kind of diagonal movement? Oh, yeah. It probably won't work for we'd have to figure out the slope of the line that connects the two corners. Because I guess we could do 8 and 6, because it's 800 by 600. So yeah, if we want to hit the corners, we can make, I was right there. We can make a Vx that was 8, because it's 800 wide, and 6, because it's 600 tall. And we could get it to go back and forth between the corners. And we'll just hit the corners. Just hit right in the corner, and both of those conditions will trigger. And so it'll change both of them. And that's why that works, or that's how that can work. Yeah, obviously, makes for not a super great game. Hey, does our code still work for clicking? This is a little bit awkward because it's so small. Maybe I'll just make it a little bit bigger. Oh, actually, I don't know if it matters, to be honest. I don't think I changed my code. There's one last thing. Now that we got it moving around, we probably should do our evaluation code as well. I'll put this back to 200. So, can I still click on it? And the answer is kind of no. I'm definitely clicking on it in the corners. So what do I have to change? So this is where my ellipse is now. And if I go to my clicking code, this is what I'm doing here. But it's not quite right anymore. What's got to change in here? Because it's no longer at 400, 300, right? Well, it might be, but chances are it's not. Yeah, the new center of our ellipse is just x and y. So I can change that to now x and change that to y. And wherever our circle goes, and this is in the mouse release function, by the way, in case you've had a whole weekend to forget and a StarCraft day to forget what we were doing before. In the mouse release section, instead of hard coding in the center of the target being at 400, 300, or wherever you had it, we can now make that a moving target by adding x and y to our mouse release function for the distance. This is pretty abstract now, isn't it? It's like, hey, the distance between this mouse coordinates, which we don't know when we're programming, and the center of the circle, which we don't know while we're programming, is less than 100. And that's still, I guess, known information. So let's see, does that work? I'm kind of bored of the target kind of bouncing from corner to corner, but we'll just do it for now. Yeah, looks like it's working. Okay. Yay! I can still miss. And it still works okay. Okay, so I'm just going to summarize the three things we've done so far, and then I think the most interesting question will be, how do you get it to like start in an unexpected direction? How is it that you can make it kind of choose its own direction? So here's the story. So first of all, the things we've done so far is we made our ellipse have a variable center. That's really important so that we can change those variables to create movement. And this is how we're doing the movement. We've made a second set of variables, Vx and Vy, which represents how much the target's moving in the x direction and how much the target's moving in the y direction. Whether or not Vx is positive or negative determines whether it's moving to the right or to the left. And then how big that number is determines how quickly it's moving. Same with Vy. Vy determines if it's moving up or if it's moving down. And the size of that number determines how fast it's moving in that direction. And then we found out that, hey, if the positive and negative aspect of those numbers determines the direction, then bouncing is just a matter of flipping the negative sign. If it hits the top or the bottom, that's about flipping the negative sign on Vy. If it hits the left or the right, it's about flipping the negative sign on Vx. Because we want it to come off with the same speed, we just need to change that negative sign to either not be there or to be there, depending on the situation. And then, last but not least, to make everything come together, we decided that this has to change as well to include the circle's new center, which is a set of variables, which might feel a bit weird. Anytime you add in variables to something, it gets a little more confusing. But hopefully you see why that's the center of the circle. And those numbers, we don't have to know them when we program it in. We just know x and y will have the circle center. So last thing we're going to do is... Wait, what else? What did I say we were going to do? Sorry. Oh yeah, we're going to randomize it, right? We want it to choose a random direction. So there's a couple of things you could do. I'm going to do the simplest possible way. And we're just going to choose random numbers. I think this is the first time we've done random numbers in this class. Is that true? Yeah? Man, this function will be all sorts of fun. You're going to enjoy random. So instead of choosing some numbers, I am going to set Vx to a random number. And here's how you do that. You just say random, and then 2 parentheses, and then you type in the range of the random numbers in here, in the parentheses. So I want it to be maybe negative or maybe positive. And maybe the maximum speed I want to start off with is like 5. So I'll type in random -5, comma 5. So in other words, Vx is going to be some random number. At smallest, it'll be -5, and at largest, it'll be +5. But it could be any number in between, with an equal chance of any number in there. Same with Vy. I'll do the same thing. Random, -5, +5. Be really careful about the order when you're using random. This number here, the first number has to be smaller than the second number. If you don't do that, weird things happen. I don't even know if it runs, to be honest, but I guess we could verify that. But always make sure this is the smaller number and this is the larger number. So if we run, you'll see that it'll go in a unpredictable direction. Let's start again. Very different. Start again. Hey, look at that. It's random. If I run it enough times, you'll start, and you guys will probably run it lots of times as you're testing your code, you'll start noticing there is, I don't know if it's a problem or not, but there is something that's a little bit unsatisfactory. And the larger we make this range, the more obvious that becomes. So I'm just going to make this like 15, just for a second. And watch how much variety of things we get. We start off, that's fine, I guess. This looks pretty hard. That's all right. Notice how much slower that is than the other two? We have no real control over the speed with this technique. We're not like setting a speed. We're just kind of randomizing everything. The directions are getting randomized and the speed gets randomized. So there's no way to sort of set the... Oh, I mean, that's not true. We're going to find out later on. There's a way to set the speed. And that's going to involve the Pythagorean Theorem, which I'm going to make optional, but it'll definitely be a thing that we can try. And I always enjoy that because, I don't know about you, but when I was in high school, the Pythagorean Theorem was a thing I memorized. I was like, triangles. Woo! Like, it wasn't really too, like, I wasn't personally excited about triangles. But it turns out, like, if you look at all movement in video games, it's all triangles. Everything that's moving around is triangles. And so things like the Pythagorean Theorem and trigonometry, which some of you haven't done yet, are like the masters of video game math. All that stuff is what makes everything move around in video games. And so that's going to be, I think, interesting to do. We'll save the problem of sort of setting the speed and choosing sort of a random direction for another class. But hopefully this gets you going in the right direction. So I'll leave you with a couple of things to do right now. What I think would be a good exercise to do is make it so that instead of your target hitting with the center, colliding with the edge of the screen, make it so that the edge of your circle collides with the edge of the screen. And so you're going to have to modify some part of the code that we did. And in doing so, that'll definitely help you sort of sort out your understanding of some of that code. So see if you can make it happen so that the circle edge is what collides. And then after you get that working, I don't really have a lot for you to do, honestly, because I want to now come around and get the Sketchpad projects marked. So you could, if you have any inkling about how you might be able to use the Pythagorean Theorem, you could experiment with that. But I imagine most people will be like, what now? don't want to worry about it. So that's okay. So if you want to spend the rest of the class just working on your game over screen and your intro screen to add some interesting animation to it or other factors to it, that would be a fantastic use of your time as well. So I guess we'll call that good enough for now. And I'll stop the video